Hello students, good morning. So today we will resume with our previous session. We will continue with the previous topic. That was about geothermal energy sources, in which in previous class we found some interesting phenomena. Okay, so today also we will continue the phenomena as well as the how we will make use of this energy for our power production. Okay. So before going into the power production, let us see some of the interesting phenomena happening in geothermal energy. Okay, so those phenomena are going to be familiarized to you first. They are very interesting. Even whether you study for exam or not, it would be very fine to know this phenomenon. So those phenomena are enlisted here. First geothermal phenomena is called fumaroles. Then we have geysers. Then we have hot springs. Okay. So let us familiarize one by one. What is actually fumaroles? Okay. These are all geothermal phenomena or geological phenomena happening due to the heavy temperature within the core of the earth. Okay. But these are visible outside. Okay. How they are visible, let us see. First come with fumaroles. Okay. Fumaroles are actually a huge smoke-like thing emerging out of earth crust. In somewhere on the earth crust, there will be some opening. There may be some long hole. Okay, originating from the very core of the earth, maybe across the crust, through which what happens? Hot steam mixed with many gases like sulfur dioxide, carbon dioxide. Okay, so these kind of gases get mixed up and then come out. The visual show such a fumarole. Okay, or which is live. Okay, the figure shows a live fumarole. What is happening is due to high temperature, bottom magma is there, hot rock is there, where maybe nearby area there may be some water resource that when it comes in contact with this hot rock or magma, high pressured steam is formed. Okay, so these steam, whenever it get a chance to come out, they may rush out. Okay, rapidly. During this their passage, they may come in contact with some such sulfur deposit or coal deposit. So what happens due to high temperature? Sulfur dioxide may form when sulfur burn at high temperature. When it come across with the carbon or coal, due to burning of coal, carbon dioxide may mix with carbon monoxide may mix up with this thing. So they come as a mixture together outside. So such combinations are called fumaroles. Okay, in many parts of the world you can see this phenomena, especially at the junctions where one continent joined with another continent. Okay, so fumarole is a natural geothermal phenomenon. Fumarole is basically occur at opening on the earth crust. Wherever there are opening or holes, often it will be near to a volcano which emits high pressure steam and gases such as carbon dioxide, sulfur dioxide. That is what I told you. Okay, it may be hydrogen chloride, it may be hydrogen sulfate. So the composition depend on the place where there is a coal deposit, there may be chance for carbon dioxide. If there is the sulfur deposit, there may be chance for emission of hydrogen sulfate or sulfur oxide like that. Okay, so that depends on the composition of that particular area. Anyway, it is a wonderful phenomena. Many tourists go to watch such sites. Okay, there are many such wonderful areas on that. Oh, so the steam forms when the underground water sources come in contact with a hot rock or magma. So this is the original reason. Okay, original reason is that so for example in the figure you can see is a water reservoir, thin water reservoir that is in contact with the magma outside or hot rock. So that what happens is in millions of years this water gets heated up and up and up, and high pressure is generated. So the steam is existing under high pressure for millions of years. So due to high pressure, some opening may develop on the F-crust. Through that opening, these high pressure steam come along with a mixture of carbon dioxide, sulfur dioxide. Like that. So that is what we call a fumarole. Okay. So these are other visuals. You may get a lot of visuals when you Google out. You can see a lot of such photographs happening in many parts of the earth. So next interesting phenomena is called geysers. Geysers. You can see a water fountain like structure here. So this is a geyser actually. These are different visuals of geysers. So what is happening in a geyser is that steam is coming out with high pressure. Here there is no smoke, there is no nitrogen oxide, there is no carbon dioxide, there is no sulfur dioxide. Only pure steam is there. That means it is similar to a fumarole, but what is the difference? There is no gases, other gases other than pure steam. So it ejects out with high pressure. Okay. So for which there should be constant water supply within the underground. Then only it can happen. Otherwise, what happens? After a few spray or after a few fountain formation, the phenomena stops out. But here it is an eternal phenomena. There are such parks in the United States. You may be knowing about Yellowstone National Park. One of the video I shared with you, in which you must have seen this kind of fumaroles happening in Yellowstone National Park in USA. Okay. So this is yet another geothermal phenomena. The reason is obvious. What is the reason? The reason is because at high temperature steam is formed at underground and through some opening they come out. But what happens whenever the water comes out? Again that water is replenished with some other sources. So there is a constant water source, plumbing source by which this fountain, this geyser is maintained for thousands of years. Okay, there are live geysers and there are dead geysers. Means due to the shortage of water, many geysers have been stopped and many geysers have been still running or still active. So this is one such geyser which is still active. So this is a marvelous visual, marvelous sights in many parts of the world. Usually it forms as a tourist destination for tourists. So it looks like a hot spray shower. So geyser require what regular water supply and a source to provide high intense heat. Okay, these are two essential things. Constant water supply is required and high intense constant heat. And a natural plumbing system to ensure movement of steam and the heated water moves upward through through certain halls, fine narrow halls. It moves upward through the crust and emerges out through a narrow opening in the crust. So that is why the fountain is formed. Okay, just like in a garden, you must have seen such as water fountain. The only difference is that they are natural water fountain, hot actually. Artificial water fountains are usually not hot, but it is hot as well. Okay. So this is another geothermal phenomena which can be found in many parts of the earth. And the third one is called hot spring. So hot springs are just like water pond, but the water in it will be very hot or maybe boiling, but not forming fairly large quantity of steam. The water may be boiling or very warm. Okay, so you can see a visual here. One donkey is taking a bath under a hot spring water taken from a hot spring. Okay, in many parts, again this is even in winter, polar regions, you can see hot spring sources. Okay, so in the absence of a constantly running natural plumbing system as required for a geyser, The water supply emerges out through some narrow cracks in the crust with low pressure and forms a stationary hot pool. Okay, so this hot pool has a lot of properties also, because it may contain a huge amount of sulfur content, for example. Sulfur content, if there is sulfur content, so this water is suitable for curing many skin diseases. Understand? So even in India, we have such hot springs located in the state of Himachal Pradesh, where those places are places for pilgrimage also. For many people, it's a place for worship, and people even boil rice in such a hot spring. Okay, these are all funny things, funny aspects of hot springs. Okay, water is so hot that you can even do cooking with that water, and people used to take a bath in it, by which many your skin diseases can be removed. Okay, so that is what is shown here. Such hot spring water usually shows low to therapeutic properties. You can treat many skin diseases. This has been there for thousands and thousands of years. Okay, in many parts of the world, people used to take bath and get cured their many diseases. Understand? So these are the three different geothermal phenomena that we discussed, starting with the fumaroles, then with the geysers, and then with the hot springs. Okay. So all the three phenomena are illustrated in a figure. Here is a hot spring. Water just comes out and stay back in a hot spring. Whereas in a fumarole, what happens? High pressure steam is coming out. The moment it comes out, it gets evaporated and forms vapor, and that is mixed with many other gases. Okay, so it's a thick fog-like structure. And whereas in a geyser, what happens? There is no other content, only water is there. It is coming with high pressure and comes out and forms geyser, what is called a geyser. Okay, so the temperature of the geyser will be too high because it is coming out of boiling at high pressure. So it forms like such a water fountain like structure. So this way you can illustrate all the three geological phenomena. Okay. So basically it is due to the temperature drawn from the very bottom of the earth, which is very closer to the magma region. Okay, from magma region it is getting the required temperature and the water is getting boiled to high pressure, just like the water boiled in a pressure cooker. Okay, so in a pressure cooker the temperature of the water may be 200, 250, 300 like that. Okay, not 100 degree. At 100 degree water just boils, but at the 200 and 300 degree Celsius water boils, and that water is called superheated water. Okay, when water is superheated, when it comes out through a small nozzle, it may form heavy steam. Okay, so that is what is happening in a geyser. These are all visualization of hot springs and geological structure, how geysers are formed, how hot spring is formed, how fumaroles are formed. Now let us come to our basics topic. We were talking about the geothermal energy resources so far, and these geothermal energy resources have been classified into the following group. First one is called hydrothermal convective system, and second one, before going to the second one, you can see that hydrothermal convective systems are again subdivided into Vapour-Dominated, liquid-dominated, and hot water field. Okay, so these three classifications are there for hydrothermal convective system. And the second one is geopressure resources, and the third one is petrothermal or hot dry rocks, and the fourth one is magma sources, and the fifth one is volcanoes. So let us see one by one. Okay, first beginning with hydrothermal convective system. Here it's simply hydrothermal simply means that the water reservoir, underground water reservoir, will take out the thermal energy from the magma region or from the mantle region and get heated up. So in case one, it may form pure vapor. Okay, vapor dominated means majority of the content will be vapor. not much water. And the second kind of category, there may be hot liquid. Okay, so that means steam is less, water is more. So this is called liquid dominated. And the third category, hot water. Water is not so hot, but it is still hot. So you find some application. So as far as the first and the second category is concerned, we can use both category for power production. Both vapor dominated steam field and liquid dominated steam field can be used for power generation by spinning, by turning some turbines in suitable form. Whereas the hot water field one cannot use for any power generation, other than many other heating applications, for room heating applications, for domestic applications, like that. Okay, so let us focus on these three categories first. Okay, so starting with vapor dominated dry steam. In a vapor dominated system, it is very comfortable and most useful for power generation. Directly deep well is drawn in different parts of the crust wherever such sources are available, and steam is taken out. When steam is taken out, along with steam, rock pieces may come out, sand may come out, mud may come out. So these things are being removed by certain technology. Okay, understand? So alone, steam, we need steam alone. Okay, so what is done? Steam is extracted from the well and cleaned in a centrifugal separator to remove solid matter and directed towards the turbine. Okay, that I think it is clear. So when it is coming up, you have a mixture of steam, high pressure steam. You have stone, rock, sand, mud, and everything. That is filtered off by some technology. The videos of which I have already shared with you. You can watch it once again. And the pure steam is taken out. It is high temperature steam, and that is used to spin out the turbine, and resulting pros are very much clear to us. Understand? So once the work is done, the steam is no more steam. Its temperature lowered. It get into water. That water is again sent back to the underground, because once you start taking the water from the very bottom of the earth, water may get exhausted. So you have to replenish it. You have to refill it. So this water, this condensed water is again packed into those areas so that it can be further boiled and taken further back out. Okay, so that is the process then. So exhaust steam is condensed in a condenser and re-injected at some distance deep into the ground. Okay, this is done. Very simple process. Here the idea is clear. You are getting pure steam. Understand? So that steam is used to produce power generation. Whereas in the category 2, the liquid dominated dry steam. So here liquid is more than steam. Understand? So we do a process called flash steaming. Flash steaming means when you bring out high temperature water to atmosphere, within the underground water is at high pressure. Okay, it is not at steam. But when you bring it out, it automatically becomes steam because of the pressure and temperature. Understand? Just like in a pressure cooker, inside the cooker water may be in liquid form. Suppose you take the whistle out. As soon as the water comes out, it forms steam. Whereas inside the cooker, it may be water, but outside it may be steam. Something like that happens here. So such sources produce mixture of steam and hot water, but mostly hot water. But that hot water, when it is brought out, or when you lower the pressure, what happens? It suddenly turns into steam. So that process called flash steaming. By reducing the pressure, you can make it steam. So once it is steam, you can make use it to do some work. Such plants are cost effective and when source temperature is above 175 degrees Celsius. So temperature is very high, so you can use it. And by flashing process, you get a high steam and turbine can be rotated. And you can classify the two types depending on the temperature. If temperature is above 175 degrees Celsius, we call it high temperature plants, and if temperature is below 175 degrees Celsius, we call it low temperature. So then let us see how they will work, high temperature and low temperature. In case of high temperature plant, what happens? This is a high temperature plant. When it is drawn from the underground, it is still in the liquid state. But when you begin a chamber and you reduce the pressure, suddenly, when water pressure is very high, it remains in liquid state. But when pressure is lowered, what happens? Rapid boiling occurs and flashes into steam. This water suddenly is converted to steam, high pressure steam, and you can use it to spin your turbine. Okay, that is a working principle of a high temperature high temperature field, liquid dominated high temperature field. Okay. So here steam is separated and you can use to spin the turbine. Whereas in a low temperature field, where temperature is less than 175, what we are doing, we are making use another procedure that is called a binary cycle. In a binary cycle, you have the steam here. Okay, you have the running high temperature steam here. Its temperature is less than 175. So what you are doing is, you will make use this liquid to boil another low vapor pressured liquid. Okay, so you have water here. For example, you have water here. Its temperature is very high, maybe 170, maybe 100, maybe 150. What you are doing is, you will run this water through a heat exchanger. This is one cycle through which you are running high temperature water. This is another cycle through which you are running another liquid. It may be alcohol, it may be benzene, it may be pentane, okay, butane, like that. So what happens, that they are high vapor pressure liquid, so they suddenly boils, they suddenly form steam much faster than water. Okay, they form vapor much faster than water. So what happens, once they are water, then their ability to do work is very high. Their ability to do work is very high, so that they can use to spin your turbine. So such cycles are called binary cycle, because you have two circulatory systems. One is water taken from the underground, whose temperature is very high, and you have the secondary cycle, where you are using another liquid, some other liquid like pentane, like isobutane, etc., running through it, because they boil very fast, much faster than water, so they can be used to operate the cycle. Okay, here difference is only in the binary cycle. The previous case, we didn't use any binary cycle. We had water, we used to convert into steam by flash steaming process, and made using rotating turbine. So here working fluid is other than water. That is a difference. And once the water is used to boil this liquid, its energy is lost, it is cooled down, you can again use it to fill the underground storages. Okay, replenish. So exhaust water from the exchanger is fed back to the underground to replenish water storage. That is done. Understand? So I think the idea is clear. And the third category of hydrothermal convective system is hot water flow. Okay, here water pressure is not so high. So what happens? The emerged water from the holes and the openings on the crust, they are stagnant, means stationary. They don't move. They don't form any spray. They don't form any fountain. They simply get stuck in a small pond-like structure. For temperature is low, it may vary from 20 degrees to 150, and you can use it for various other purposes, residential, industrial purposes. You cannot use it for running turbines. And you can, again, water can be re-injected into the ground after extraction of heat energy. Okay, various applications, especially in polar, cold regions, very winter, those areas where they feel heavy, very intense winter, such places find a lot of application with such hot water, because it is naturally free of cost available on the earth. Understand? Uh, so this is about hydrothermal convective system, the third category. And now we can summarize it. We have so many geothermal sources, in which the first category was hydrothermal convective system, and we split up into, we categorize them into Vapour-Dominated system, liquid-dominated system, and hot spring. Okay, and again the liquid-dominated system is classified into high temperature system and low temperature system. High temperature system worked by flash steaming process. Understand? Flash steaming. Okay, hot high temperature hot water is when it is suddenly exposed open to atmosphere, when suddenly the pressure is lowered, they form steam, and such steam can be used to steam your turbine. Whereas in a low temperature system, you make use the hot water to boil, to evaporate some other liquid, pentane, butane, like that, and that's evaporated vapor is used to drive your turbine. Okay, so this is the overall classification of hydrothermal convective system, and the remaining categories we will come across, or we will see in the next module. Understand? Okay. So, this is a small topic. So, what is the difference between a conventional thermal power plant and a geothermal power plant? We have conventional thermal power plant where we may be using a coal, we may be using some fuel, petrol, diesel, like that, and we have a geothermal power plant also, because we have already seen so many geothermal power plant where turbine is driven with thermal energy drawn from such a geothermal centers. So what is the difference? So these are the differences. For a conventional geothermal system, temperature is much high. Okay, temperature of a conventional, for example, a coal-based thermal power plant, its temperature may go as high as 540 degrees Celsius, and the pressure may go as high as 160 atmosphere. Okay, normal atmospheric pressure is, our pressure is 1 atmosphere, but the pressure existing in such a system, coal-based plant, may be 160 atmosphere. Okay, whereas in a hydrothermal or a geothermal plant, the temperature may be hardly 165 degrees Celsius, and the pressure may be 7 atmosphere. This is one of the crucial differences between conventional and geothermal plant. And the efficiency of a conventional plant is ranged from as 35 to 40%, whereas for a hydrothermal plant it may be as high as 15% only. Okay, much less than that of a conventional coal-based thermal power plant. This is yet another difference. Okay, and hydrothermal plant produces its own cooling water, whereas in a conventional plant, cooling water is taken from the external sources. Okay, so that is another difference. Okay, these are the few differences between conventional thermal power plant and geothermal power plant. Okay, so with this, let us conclude today's session. And here is a simple assignment for you. Distinguish between fumaroles and geysers. Okay, we have already talked about fumaroles. We have talked about geysers. You find some application, find some difference. Write the differences as points. Okay, at least you can include, 3 points. Okay, 3 points you write on fumarole, and 3 points you can write on geysers. If you don't get enough points from this particular module, you can search out any internet sites and find out such differences. If possible, you can write even 4 differences. Okay. So hope you can do it very simply. So with these comments, let us conclude today's session. Hope you enjoyed the topics well. Thank you all. Goodbye.